In our second example, notice that we have a situation here where we have 3x squared, but there's no middle term. There's no number with an x, right? So this is x to the power of 2. There's no x to the power of 1. We just have our leading term that's squared, and we have 4. So that's a unique situation, and we're going to need to use what I normally call a placeholder in this particular type problem to represent that middle term that's missing because it's 0. However, we still are going to start out similar to how we done the other one. So the first thing we're going to do, I'm going to write step 1, is we're going to modify our divisor. So our divisor is this orange one, x plus 5. So I'm going to go ahead and I'm going to rewrite it, and I'm going to set it equal to 0. We do want to go ahead and use inverse operations to move that value over. That cancels, and I'm simply left with x is equal to -5. So this is my modified divisor, and I'm going to go ahead and use it to do our division. So I'm going to go to our second step, step 2. We'll go ahead in step 2 and draw our symbol to do the division. And then we'll go ahead and write our coefficients for this term. So for instance, on this first term, right, my leading term, I have 3 for my coefficient. Notice there's no middle term. In other words, when I say middle term, I should have some number. I'm just going to put a 0, x, right, because this is x to the second power. So this would be x to the first. So in place, because it's not there, I am going to put a 0 in it, because you do have to have a value for each one. So for instance, if this 2 was a power of 4, then we'd also have to have a value for the power of 3, x to the power of 1, and so on. So for every x, right? So it depends on how high this leading term is. Now this one's only x to the power of 2, so I just need to have 1 for the x to the power of 1. So because x to the power of 1 doesn't exist in here, I'm going to go ahead and put a 0 in its place. And then I'm going to take my constant value, my 4, and bring it down. I'm also going to go ahead at this time, and I'm going to write my divisor, my modified divisor I like to call it, here on the outside. And we're going to start this just the way that we started the other one. I'm first going to go ahead and bring this down, so this becomes 3. And now what I want to do is take my modified divisor, and I'm going to multiply that -5 to this 3. And then I'm going to write the answer up at top right here. So -5 times 3 is going to be -15. So underneath this, I'm going to write -15. And then I'm going to bring that answer down, and that just becomes -15. And then I'm going to take that modified divisor, and I'm going to now multiply it to -15. And write that answer up on top. And 5 times 10 is 50, and 5 times 5 is 25, so that's going to be positive 75. So I'm going to write positive 75. Now if I continue this process, I'll take that 4 and add it to positive 75, and that gives me 79. Now the final thing I'm going to do is just like the last videos. I'm going to take the 3, the -15, and positive 79, and now we're going to go ahead, and this is going to be part of our answer. So this first term here, it goes with my variable x, so I have 3x minus 15, and that's a positive, so I'm going to put plus 79 over my divisor, which is x plus 5. And since this last value didn't give me 0, this does represent a remainder, and that's why we write it as this in this way, in this manner. And that is your final answer.